Hello everyone, today I'm going to demonstrate the basic functionalities of bhOWL, which is developed by the Institute for Computational Design and Construction, Department for Computing and Architecture, ICDCA, University of Stuttgart in collaboration with bhOWL using the open source interoperability platform bhOWM. I have opened the demo file which we provide on our website, and on the left side you can see the Rhino viewport with a bunch of Rhino geometry. And on the right side here, you can see the Grasshopper canvas. And the first thing we want to look at are the basic components. And afterwards, we're going to go through over how to convert different geometry to graphs and also how to visualize it in a graph database. So starting with the basic components, we have adapters and actions in our plugin. And each action requires an adapter. So here, for example, we have our push action, which enables us to convert objects to a graph, and we do this by plugging in an adapter. So here we have our TTL adapter, which will create or specify the format that the objects are going to be converted in. So in this example, a TTL adapter, which will convert the objects to a turtle format. We also have other adapters like a GraphDB adapter, which will push the data to an online graph database. And we also have the pull component, which enables us to convert a graph back to the objects. So I would say let's just get started. So we can start really basic with this small example I've prepared using just Rhino geometry that we can convert to a graph. So here I have some basic Rhino geometry. We have a point, we have a curve, we have a mesh. So here the point consists of 3 coordinates, x, y, and z, that we can also parametrically change. Then we have a polyline with 3 points. And finally we have a mesh where we can change the radius of the mesh sphere and then also the resolution. Which then brings us to our bhOWL components. So first we have our push component with a toggle. And in the push component, as mentioned earlier, we plug in an adapter, in this case the TTL adapter, which also takes basic graph settings. For example, ontology title or the description, TBox URI, ABox URI, and then if we want to serialize the geometry to base 64 or just leave the plain geometry in the data file. I've already plugged in our point with the coordinates, and this goes also into the push action in the objects inputs. And then if we toggle this to true, then we can see in the output first of all our graph file as a turtle format, and then also a success output, which will tell us as a boolean if the computing was successful or not. Then up here we have our headers, which have our prefixes and the data we defined in the basic graph settings. So for example, the ontology title or the ontology description. Then if we scroll down a bit further, we can see in the classes section, this is our classic TBox, so with all the classes defined. And then if we scroll down even further, we come to the individual section, and here there's the actual data, so a point with a x, y, and z value. And then if we make this a little bit bigger, I can also show you that this will change in real time. So for example, if I slide here the x slider, we can see the coordinate not only changes on the canvas, but also in our graph file. We can also do this with the polyline. Now we have a lot more points because the polyline not only consists of the 3 points, so here the first one, the second one, and the third one, but also the polyline itself, which again has a few control points. So in this case 3, we can see RDF 1, 2, 3 here, and the GUIDs of the individual points, and here are the points again. We can also do this with the mesh sphere, and now we have a lot more points because we have a lot more vertices in the mesh sphere. And you can imagine that this can get quite heavy on the output, so there's also the opportunity to save this as a file path specified in the TTL adapter. So now we can come to the more interesting part, which is not only that we have Rhino geometry, but we also have bhOM objects and custom classes. So here, for example, I have a room object that we can see in the Grasshopper canvas, and we have the similar setup with our push component and a TTL adapter. Here we have the room object, which is a bhOM object, and we can get this by hitting Control, Shift, and B, which brings up the search bar, and now we can search for room. And here we can see that we have a BHoM architectural namespace, and here we have our room with a curve parameter, a location point, and a name. So if we select that, we can see this is effectively the same object that we already have on the canvas, and we can also see the name space in the object output. But even though bhOM has many objects already predefined, we might want to create a custom object, so something that is not defined already. We can do this by coming up here, create custom object, and then similar to other Grasshopper components, we can of course modify the inputs by adding more inputs to our component and also being able to rename them. Down here I've already set an example. For example, here I have a custom object which is a building with the name, the year it was constructed in, and the site location. And also we can nest custom objects, so here I've added another input to our building, which is architect, just by hitting the plus down here. So I've also added the architect of the Farnsworth House, Mies van der Rohe, with his name and his date of birth. Now we can also demonstrate this on a more concrete example. So here I've made the Farnsworth House again with bhOM objects and custom objects using Rhino geometry as well. So the setup looks the same as before. We have a push component with a TTL adapter and graph settings. So going over the individual objects, up here we have the architect. Then we have our room object, which is defined as a curve parameter here, the ceiling slab, the floor slab of the main building, and the floor slab of the garden. And then we also have the columns, so the columns in the yard, and then the columns of the main building with different lengths, but both have the same structural profile, which consists of different inputs, for example, the material, in this case steel S235, with its specific density, and then the profile is also defined with a diameter and a name. Now, if we convert this to a graph, we can see that the file is a lot bigger, has different types, so not just geometry, but also serialized nested inputs with different strings. So for example here the architect, then the column points, the perimeter, the slabs. So up until this point we've mostly only worked in Grasshopper. So what I want to show you lastly is also how to work with graph databases, so also being able to push the files to a graph database to be able to visualize it and work with the graph. For this, our setup looks quite similar. Again, we have our push action, which has a room object that is plugged in. But now the adapter is different. So now we use a GraphDB adapter that utilizes repository name and a server address. So to utilize this, we first have to open GraphDB. And GraphDB will look like this in your browser. So we have a local instance running here, which you can see from the URL. And then here you can see we have no repositories or data in the GraphDB so far. And also if we go to setup and repositories, we can see there's no repositories here as well on our local machine. So if we go back to Grasshopper now, what we can do is use the GraphDB adapter where we specify a repository and the URL we looked at. And we can see our basic graph settings like earlier as well. So if we toggle our push component and our adapter to true, we will have a GraphDB login pop-up. Because we have a local instance running, we don't need a username and password, just a server address. We hit OK. And now if we go back to Firefox and refresh the page, we can see that now there is a repository being created. And if we choose that repository, we can also see that there's already data inside. So the room object. And we can also see that there's explicit and inferred knowledge. If we come to settings and autocomplete, we can toggle this button, which will just make the search in the repository much easier. So now if we come, not monitor, but explore, we can go to the visual graph. And here we can search for objects because we've enabled autocomplete. If we type in room, we will see the full namespace already here. And here we can see a visual representation of our room with all the objects that are connected to it. So also, for example, the location point. And we can expand this. And here we see, okay, in the location, we also have our point, so the Rhino geometry. And if we expand this even further, we see, okay, this point contains a lot more data, but also the X, Y, and Z value. So this concludes our small demonstration of the demo file for bhOWL. If you want more information, we have the documentation on GitHub, and you can also read more about bhOM on bhom.xyz.